Welcome back to The Explainer. Today, we are treating our time together not just as a deep dive, but as a full-blown magic show. We're going to pull back the curtain and reveal the actual, concrete science behind some seemingly impossible visual tricks. So get ready to have your mind blown just a little bit.
Okay, let's dive into this. It sounds like something straight out of a fantasy novel, right? Objects vanishing, floating in midair, shape-shifting on command. But what if I told you that you don't need a magic wand or special powers to make these things happen? You just need a basic, solid understanding of the physical world. Today, we're going to challenge your assumptions about reality by looking at phenomena that look like pure magic, but are actually grounded in brilliant, perfectly measurable science.
So, here's our playbill for today's performance. We'll kick things off with the magic of science, then move right into the disappearing glass illusion, the floating ball trick, a shape-shifting liquid, defying gravity with magnets, and finally, we'll wrap up with why the real magic is just physics.
Part 1. The Magic of Science. Everyday materials. Impossible sights.
Look, we aren't using trick mirrors, hidden wires, or trapdoors today. We're using everyday items you could probably find in your house right now, like cooking oil and ping pong balls. Now, every great magic trick follows a specific structure, right? The setup introduces the ordinary items. The trick is where the extraordinary thing actually happens. And the prestige? Well, for us, it won't be a magician pulling a rabbit out of a hat. Our prestige is going to be that super satisfying aha moment where we reveal the undeniable physics driving the whole illusion.
Moving on to Part 2, the disappearing glass illusion, vanishing in plain sight. Let's set the stage here. Picture this. You've got a large glass beaker, a smaller one placed inside of it, and just some standard cooking oil. You start pouring the oil into the smaller beaker, letting it overflow completely into the larger one. And as that oil level rises, the smaller glass literally completely disappears. It doesn't dissolve, obviously. It just vanishes into thin air. Actually, scratch that. It vanishes into thin oil. Your eyes are absolutely telling you it's gone. So how on earth is this visual wonder possible?
And here is our prestige. It all comes down to how we see. We only see objects because light bounces off them or bends right through them. When light passes from one medium to another, like from the air into a piece of glass, it changes speed and it bends. And the degree that it bends is called the index of refraction. So, the absolute crucial point here is that the specific cooking oil and the small Pyrex glass beaker share the exact same index of refraction. When the light passes from the oil into the beaker and back out again, it doesn't change speed or direction at all. Because the glass doesn't bend the light any differently than the oil does, the glass becomes completely invisible to our eyes. Wild, right?
All right, Act 3, the floating ball trick. Let's uncover some levitation secrets.
For this levitation secret, we're trading out our beakers for a heavy-duty leaf blower and a simple ping pong ball. Now, if you point a leaf blower straight up into the air and place the ball in the stream, the upward force of the air matches the downward pull of gravity, making the ball hover. Okay, that makes perfect sense, but the real trick happens when you tilt the blower to the side. The ball actually stays locked in the stream, hovering steadily at an angle without falling out. What invisible forces are keeping it suspended like that?
To understand this, we need to look at two brilliant scientific principles. First up, Bernoulli's principle. As the air hits the ball, it has to speed up to move around it. This faster-moving air creates an area of low pressure completely surrounding the ball, essentially locking it right into the center of the airstream. Second, we have the Coanda effect. This states that a jet of fluid, like our fast-moving air, tends to stay attached to a convex surface, like our round ping-pong ball. So, if the ball wobbles even a little bit toward the edge of the stream, that fast-moving air wraps around the curve of the ball and literally pulls it right back into the center.
And this brilliantly illustrates something way bigger than a tiny ping pong ball. These exact same physics concepts explain how massive, insanely heavy airplanes manage to fly through the sky. As an airplane moves, the pressure near the wings changes thanks to Bernoulli's principle, and the Coanda effect ensures that the fast-moving air sticks to the shape of the wing, which is what keeps the plane aloft.
Act 4, the shape-shifting liquid, the non-Newtonian wonder.
We're heading back into the kitchen for this one, to mix a super simple 1-to-1 ratio of cornstarch and water. This creates a mixture that utterly defies the ordinary laws of physics. Imagine dipping your finger gently into a bowl of this stuff. It goes right in, feeling exactly like a thick liquid. But if you tap the surface hard with a spoon, it instantly hardens, stopping the spoon right in its tracks. You can even scoop it up and mold it into a solid ball in your hands under pressure, but the absolute second you stop rolling it, it melts and flows right through your fingers. If we look at this molecularly, it makes total sense. When the mixture is at rest, the water molecules are moving freely between the starch particles, acting exactly like a liquid should. But under sudden impact, those larger starch particles are forced to tightly compact together. They trap the water inside, turning the mixture into an instant solid. The moment you relieve that pressure, it returns to a liquid. It's an incredibly tactile, weirdly fun scientific marvel.
Part 5. Defying Gravity with Magnets. The Copper Tube Race.
Now, what's really interesting about this setup is that we're staging a race between a standard plastic PVC pipe and a copper pipe of the exact same length and diameter. And it's super important to note here, copper is completely non-magnetic. We take two identical, highly magnetic neodymium magnets and drop them down both tubes at the exact same time. The magnet in the plastic tube falls instantly to the floor, which is exactly what you'd expect to happen.
But when you watch the copper tube, something weird, almost cinematic, is happening. The magnet is falling in extreme slow motion. I mean, it literally looks like it's floating through thick honey instead of just empty air. If copper isn't magnetic, what on earth is grabbing onto that magnet to slow its descent so dramatically?
Time for the final prestige. The answer is Lenz's law. Even though copper isn't magnetic, it is highly conductive. When you drop a strong, moving magnetic field down the tube, that movement actually induces an electrical current inside the copper itself. And according to Lenz's law, this newly induced current instantly generates its own magnetic field, and the direction of this new field always opposes the action that created it in the first place. Basically, it pushes back against the falling magnet, literally fighting gravity.
The current created in the pipe is what we call an eddy current. Think of a river's eddy current. If you've ever been whitewater rafting, you know an eddy is that spot where the water circles back and actually pushes upstream against the main flow. The falling magnet creates a magnetic eddy current in the copper that pushes the magnet back upstream, drastically slowing its fall.
Which brings us to part 6, The Real Magic is Physics, our grand finale.
Let's quickly recap the satisfying logic we've uncovered today. That disappearing glass, it vanished entirely because it bent light exactly the same way the oil around it did. Our floating ball totally defied gravity by utilizing low pressure and the Coanda effect to stick to a stream of air. Our shape-shifting liquid proved that molecular structures can change instantly under physical impact. And finally, we just saw that a moving magnet can literally conjure an opposing magnetic force field out of a simple, non-magnetic copper pipe. Because, honestly, the real magic isn't an illusion at all. It's the beautiful, structured rules of physics operating silently all around us every single day. So, I'm going to leave you with this thought. The next time you look at a simple glass of water, or play with a magnet on your fridge, or just feel the wind rushing past you outside, what invisible forces will you start to see? Thanks for joining me on this explainer, and definitely keep looking for the magic in the everyday world. Catch you next time.